My name is Glen Koehler from University of Maine. Okay, so I have not timed this talk before, but it's a fairly short talk, and Rachel's going to keep me honest. When I saw the title on the session, I was a little bit thinking, well, actually my talk is not really specific to fruit and vines. That's what I'm using it for right now, is apples. But the concept is really not even limited to crops. So I got hired to do tree fruit IPM, and I found myself constantly on the phone with growers talking about how much it rained last week or is going to rain this week, because that drives our spray schedules. And we're running all these numbers in our head, and we got these informal rules about how many inches of rain is this good for, and how fast are the trees growing at this time of year, and how fast, and you know all this, and what the temperature's doing to the spore maturity rate, and blah, 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 and you're crunching all these numbers, and I thought, you know, computers are much better at crunching numbers than I am, and we could focus on the decisions. So, but without $1 million budget, so what am I going to do? So I started grabbing weather data and paying a private vendor to send me tabulated data. It's, you know, computers, they're very smart, but they're not flexible. Everything's got to be where it's got to be, or else it just breaks. So I've never given this talk without slides either. So using those data, bringing them into an Excel, that's what Excel is. It takes numbers and turns them into meaning, into charts and graphs and analysis. So that's where this comes from, is weather was driving all our decisions. Just next one. Let's just do it with a space bar. And I'm talking to the choir here. Everybody, you know, weather drives our decisions in agriculture. So next one. So I got a little grant from the USDA Northeast Climate Hub through David Hollinger and friends. And I was telling David, I said, look, I'm paying for this weather data, and they do a great job. It's about $55 a month per site. So it's not that much money. It's for a 6-month, 7-month growing season, it's about $350 a year, which is not huge. But you start doing 20 sites a year, it adds up, and it's just one more thing to do to go chasing that money and get grant money and handle all that. And I thought, you know, I can see all this weather data online through NOAA. If I could just get a hold of those things, I could bring them in and not have to pay for it. So that's Sean, and I tried for 20 years, but I don't have the skills to get into those databases. So Sean is our Maine state climatologist, threw him a little bit of money, and he said, oh, I could do this easily. He said, his original, I shouldn't say this without Sean being here, but he said I could do that in an afternoon. Well, it took a lot longer than an afternoon. It took us about 1.5 years, but you know, he wasn't working on it full time by any means, but it took a long time. Next slide, please. So Sean runs this site called Climate Reanalyzer. How many people have seen Climate Reanalyzer? It's really worth checking out. So he wrote scripts to bring down the weather data. Next slide, please.
Next slide.
So he wrote scripts that create, you know, comma-separated CSV files, which is what Excel likes to see. He wrote scripts to bring down the global forecast system. That's what GFS stands for. And gives us the days 1 through 10 and the days 11 through 16 forecast. And he's doing it once per day now. He said it's really no problem doing twice a day or even 4 times a day. My system, since I'm running Excel, it's all automated. I don't have to sit there and tell Excel to grab the data. There's scripts within Excel that I wrote through Visual Basic for applications. I'm not sure I need it more than 4 times a day, because people aren't going to check the weather that often. But the reason for running it more than once a day is so that when you look at it, the data in the estimates are fresh. You know, they're not based on data that's 24 hours old. I want the latest and the greatest. And then that's for forecast. And then for the observations, we use a database called IRMA, which I'm sure Art can tell me what IRMA stands for. But it's sort of the improved version of RTMA. Yeah. And again, these have pretty good resolution, and they're getting better all the time. Next, please. So we're getting the usual goodies. Temperature at surface, relative humidity, pressure, precip. The databases do not have chance of precip, which is, I think, is odd, but we couldn't find it in there. So, but what he's doing, he's deriving it. I won't get into the details now. Wind speed, direction, and gust speed, cloud cover. Next slide, please. And then some little more exotic things. Your shortwave radiation coming down, that drives your photosynthesis. Long wave, I'm not quite sure how we're going to use that, but both of these are up and down. Soil temperature at 2 and 10 inches, soil moisture at 2 and 10, potential evap, that's great for irrigation. Evapotranspiration is great for irrigation. Potential evaporation, the way I'm using that is for forage drying because it has different phases. At first cut, those forage stems laying on the ground, they're still alive. They're still doing evapotranspiration. But after they get to about 60% moisture content, now you're into it's a physical thing, and it's just potential evaporation. So you need both if you want to do a good job on forage quality. And then leaf wetness, we could spend here all week talking about leaf wetness. It's a particular pet peeve of mine, but there's a variable in there called plant canopy surface water. I'm not quite sure what it is, and hopefully I can talk to you guys later, but Kevin's shaking his head. I also thought maybe we'd get something out of that. We're probably just going to go back to RH for that stuff. Next slide, please. So again, this is how it works. Sean creates these weather data text files. Right now, my vendor sends me those text files, but I pay the vendor. I don't have to pay Sean's thing. Once he gets it set up, it just runs, and it doesn't take much computer time or space or anything. The Visual Basic scripts on my end go grab the data, brings it into Excel. Excel crunches the numbers and then automatically creates tables and charts and saves those as web pages. So the growers have direct access to decision support information. Next slide, please. And just a few slides just showing how it looks. So we've got a website called Ag Radar. This is for apples, and these are just the sites we ran that year. I think that was 2 years ago. And so if you want to find out what's going on at Maine Monmouth, that's where our research station is. You click on that and you'll see, next slide. And there's a long list of things. I didn't want to have screen after screen of links, but this is how it looks. So it starts off with your basic weather stuff, and then you start getting into the different applications. This is apple scab, which is our key disease. Next slide, please. And because Excel is so good at analysis, I can turn things inside out, upside down, and sideways in terms of what does the grower want to know. And this is a key point. You really need extension, and I don't want to make myself seem more valuable than I am, but it isn't just numbers and weather and climatology. You need somebody that understands what the growers want to know, because it isn't just degree days. Degree days are an abstraction. What they want to know is, when do I do this or that? When does this insect come out? When do the eggs hatch? When does all that. So that's where decision support really gets critical. So that all aside, I want to say a few words about this is virtual weather, right? It's not a station on your farm. And I went to John's talk earlier, and that was a great talk. And I originally thought, oh, am I conflicting with John putting stations on your farm? Well, for two reasons, no. One is on-farm stations are never going to predict the weather. They observe what happened. So they're always looking backwards. And a lot of our decision making really needs the forecast information. The other thing is, in my world, I don't have a mesonet like New York does, and I don't see one coming. So I needed weather data. Now, hopefully I can tie into NOAA a little more and use some of the airport stations, but to get site specific, I need something pointed towards that farm location. So different data for different folks. You use what you can get a hold of. I think there's plenty of room for both. So Washington State did a really interesting study on using virtual weather data for running decision models. So they've got this ag weather system. It's used on 250,000 acres. The tree fruit growers out there value it at $16 million per year. And it's all great, but even Washington State, with all their resources, says, we're not sure we can keep this thing going, maintaining all those stations. Next. So the question is, well, that's great, so what are you going to replace it with? And virtual weather is great, but is it good enough to replace on-farm measurements for the observed data? Next slide. So what their comparison was, They looked at the forecast data from the National Digital Forecast Database, and they used the one-day forecast as their observations, okay? And they made the point that the station data they were comparing to aren't necessarily the truth, written on stone tablets from Mount Sinai, but this was the comparison. And they've had a number of problems with their stations. Even the one, they had to filter out a lot of noise in doing their data set for the study. You have gaps in your data sets. Sometimes the stations aren't maintained properly. You get sensor failure. Sometimes they're not at the right place. And these are all things we've seen in some of the work we've done in New England on having on-site stations. We did a study, we compared virtual to on-site stations, and my job was to see what the difference was, and I couldn't do the calculation because I didn't get a complete data set from any one of the locations. Next slide, please. And this is the basic result. So, it's a correlation. So if it was a perfect correlation, there'd be a thin white line going from one corner to the other. And these are their different locations, and they're pretty good. There's a little bit of slop around there. It's not 1-to-1, but it's pretty good. And this is for degree days. And again, they're dealing with mountainous terrain out there too, which makes it even tougher. And it's a 5-kilometer grid, and they're using the day one forecast versus the station observation. So there's already a day lag in there. That's another problem. And so this was kind of the bottom line. They decided that 3 days, if the difference in the decision support estimate, like when do you need to spray for this apple maggot? When do they come out of the ground? Okay, that's a key tree fruit pest. And they said if the difference is less than 3 days, we're not going to worry about it too much because the grower's response time is kind of in that range. So these are different life stage events in the apple maggot's life, and these are the differences between the NDFD and the ground station. Again, the NDFD is not even using observations, it's using a forecast value, and they're all about 2 days. So they considered it was good enough. Next, please. So yeah, it is clear that the NDFD data hold great promise for use as virtual weather stations. Next, please. So when I talk to this growers, and I think with my growers, we moved beyond this point. When I started doing this stuff 20 years ago, I was afraid they thought, oh, the computer's taking over my job. But I always made the point, no, your brain is still important. This is, and again, I'm talking to the choir here, but this is the future of agriculture, this part of it anyway. You're going to take this kind of data, run it through systems that do the analysis and turn it into, Art's got a great slogan on your website. What is it, Art? Data to knowledge to... But it's like turning data into knowledge. And again, this is just, this is not for my project. I do have to say that this farmer wasn't talking about the stuff I'm doing, but he's talking about using decision support from weather-driven models. And he says, he's making more informed decisions, and sometimes he finds out he doesn't need to do anything. And that's a decision too. Next. And just because I'm in crop world, and I was a little hesitant when I saw that Dr. Hristov is here, because he wrote those thermal heat stress models for livestock, I looked into this past winter, and I want to plug this in this coming growing season. There's a lot of opportunity besides just apple scab and tree fruit and crops. As the presentation this morning showed, there are a lot of weather variables for dairy cows and other livestock. And so besides the basic THI, they came up with a new one that's being run out of Oklahoma called Cattle Comfort Index, which isn't just temperature and humidity, it also throws in sunlight and wind, because if it's 90 degrees and it's cloudy, that's different than 90 degrees and being sunny. Okay? And the thing out of Oklahoma is run nationally, but it's not as good as what can be and what we can do, because it has 7 stations in Maine. It's basically airport locations, and they don't even put in the relative humidity. They just give you 3 blocks and you choose which value to use. And it's like, well, no, we can put all these things in and give you a site specific, and we can throw a forecast on, because theirs is just observational. So there's a lot of layers we can add to that. Next, please. And this is the last slide. I had a talk to our agricultural commissioner, and he's a dairy farmer, so I wanted to have something to end with. what this boils down to at the end is, so what do you do with this information if you're a dairy farmer or a livestock manager? It changes what you feed and when you feed it and how much you feed. When you move those animals, because when you move them, that adds heat stress. Just them moving around adds heat stress to their bodies. When you turn on misters and fans, because they're expensive to run. As Dr. Christoph talked about this morning, the success of reproduction in artificial insemination is driven by temperature. When you put them in the shade, adjusting bedding, all these things. So there's a lot of applications, and I'll end there.